Hello, in this video I'm going to be talking about calculus and differentiation in general. Now, differentiation is something that was made or created or let's say invented or discovered by Gottfried Wilhelm Leibniz and Isaac Newton independently. There's a controversy on that, so we'll just say that it was both of their contribution. And you may have heard what differentiation is. So basically, if you're watching this video, I'm sure you have heard it and you may be having problems with it. So differentiation is basically just finding the slope at a point, or it's also known as derivative in simple terms. All right. So let's begin by talking about what a slope is. Let's say we have 2 points. All right. So we have this one point over here. Let's call it x2 comma y2, and then we have another point, and let's call that x1 comma y1. Just decrease this size. Okay, yeah, so these are 2 points. Now what is the slope of these slope of the line joining these 2 points? Now how do we define a slope? Let's write definition over here. Slope equals rise upon run. Well, simply put, that's how slope is defined. And actually, it's that simple. I mean, that's how we define slope. So even over here, what is the rise? The rise is y2 minus y1, and the run or the amount we got on this side on the x direction is x2 minus x1. So essentially, the slope at this point, or tan of theta, where theta is this angle, equals m is equal to y2 minus y1 divided by x2 minus x1. But you say, yeah, that's great. So what is derivative, right? So basically what happens in derivative is we try to find a derivative at a point. Now, if we have these 2 points, we can find the slope between these two points. But then how do you find the derivative at a point? So let's take two more points. These are the points. Now, if we can find the slope, like when we join these two lines, we can find the slope of this line, this line. But then if we bring it closer and closer and closer and closer, we eventually reach at this point and we can find the slope at that point itself. And that's what a derivative is, because that a derivative is something that allows us to find a slope at that point. Now let's say we have point A over here and we are trying to find the slope at that point. So I'll change the color. Let's take green. So we have a line over here. Oh, alright, we have a wonderful line actually. Yeah. So this is our slope. Now what a slope is doing is we are decreasing this gap. Like we have when we had these 2 points, these two marks, this was the run or the distant amount of units we move in this direction. But when we find the slope, we are essentially bringing it down so close that we are decreasing this distance. So when this was delta x, which was x2 minus x1, for a derivative we are bringing this close to zero and not at zero, because when it's close to zero, it forms such a small triangle, and we can actually approximate it as a point. So basically this becomes a point. And yeah, so that's delta x approaching zero, which can also be written as dx, but I'm going to be talking about that a little later. So let's just I'll just talk about the notation now. I'll just rub a little bit of this, and yeah, so we have this slope over here. And now what happens is, if we have very two close points, say this is point A and this is point A and this is point B, when we have very two close points, so if we take this as x, sorry, and then this will be x plus h. And what is h? H is some value which is very close to 0 and it's to the right of x. So basically, if these are divisions, and if x is over here, x plus h is this division, just the next one, which is infinitesimally small, which is an infinitesimally small distance away from x. So h is basically infinitesimally small. So yeah, so that's what the definition of a derivative is. Now, when we have this x and x plus h, what is the function value at x and x plus h? Well, at a, the function value should be f of x, and at b, the function value should be f of x plus h. So now, what do you think the derivative would be? Well, again, it would be rise upon run, right? Because rise upon run says that it should be the difference in the y value, which is f of x plus h. So remember that this is f of x. So that's f of x plus h minus f of x divided by h. And how small is h? H has the is the limit of h approaching 0. So basically this is approaching 0. So basically what's happening is if this is the slope. I'm sorry, I'll draw a better diagram. This is just poor drawing. Alright, so I'll choose a better color. Let's take brown. Alright, so we have this slope over here. What we are doing is we are bringing the points so close together. We're bringing this point closer and closer and closer and closer, so that we decrease this distance, and even the function value sort of decreases, and then we find the steepness at that point of the graph. So at that point, the steepness is represented by this, which I've also written over there. So that's a very important formula, and that's basically differentiation, because that allows us to find the derivative or the slope at that point. And when we are doing computations or we are solving problems in differentiation, we write it somewhat like this: dy by dx, which is the same thing, because what this is like delta y by delta x, because that's the change in the y, or that's the rise, and this is the run. So there you have it. You have dy by dx, which is a way to represent the slope, and that's equal to tan theta, or the tangent of the angle which it makes with the x-axis at that point. So that's basically differentiation. I mean, that's what the meaning of derivative is. And I'm gonna be, this is a sequel, so there's gonna be many parts to it, and I'm gonna be talking about the some rules in differentiation, and some common differentiation problems, common problems. And yeah, I hope you join me over there.